Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your FiberOwl4 optical power meter for proper operation using a dual OWL multimode light source.
Now, prior to testing, patch cables and test equipment should always be checked. Usually at the beginning of a testing day is a good time to check your patch cables and your equipment to make sure they're operating correctly. Now, in this procedure, we'll be using the FiberOwl Optical Power Meter and the dual OWL multimode light source. Now, you'll see that I've gathered all the accessories that we'll need for this test. And you'll see that there are 3 patch cables, 2 of which are mandrel wrapped. This is per standards, and I've wrapped it around this mandrel, and I have a duplex cable. One for each. I need 2 cables for this because I have 2 wavelengths that I will be using potentially. The 3rd cable will be used to connect the FiberOwl in while you're doing your measurements. And then a mating sleeve will be used during this procedure to connect the reference cables together in order to check them all out just to make sure they're working okay. One thing that you need to make sure of is that the test cables and the mating sleeves are the correct connector style. One end of the test cables must match the test equipment ports, and then the other end must be able to connect into the link under test. And then in this demonstration, we're assuming that all the connectors are SC. The testers, the patch panels, everything is SC. So first what we want to do is we'll power on the testers, and that's easy enough to do. Press the power button on the FiberOwl, and then press power button on the dual OWL. And you'll see that the red indicator LED is now lit. That means 850 nanometers is active. Now on the FiberOwl, you'll see that an operating mode screen will appear. For this particular procedure, for just checking our patch cables for proper operation, we're going to be using Simple Meter. Simple Meter is already highlighted, so we will just press F2 to select. Okay, now a little bit about what's on the screen here. You'll see that the word under is appearing. What this means is that there's no amount of light coming into the photo detector of the FiberOwl. It means it's completely dark. It's because the dust cap is on. If you notice, there's a dust cap on, blocking all the light. So now what we need to do is take our mandrel wrapped reference cables and connect them into the 2 ports on the dual OWL. All right, and we'll take the dust cap off the FiberOwl, and then we'll plug in the 850 nanometer side into the detector port on the FiberOwl. Now you will notice on the top of the FiberOwl that the ports are labeled. One of them is port labeled connection light source, or sorry, caution light source, and the other one is labeled detector. Detector is where measurements are taken. This is the receiver. So this is where you will plug all of your test cables into. Okay, so plug into the detector port. Oh, and notice that the reading went back to under. What this means is that because we have a duplex cable, we plugged in the wrong side. So we need to actually plug in the other side into the detector port. Now you'll notice that there is a reading on the screen, a very low power reading of -50 or so. What this is doing, it's not a problem. This is what a power meter is supposed to do. What it's doing right now is it's measuring the ambient room light that's coming into the photo detector. So it's not really taking a measurement at this point of your fiber, but it's actually measuring the light in the room. So what we'll do is we'll connect the proper reference cable back in. And what we're trying to look for is a reading of around -20 dBm. Now notice it says dBm here at the top. That's the measurement unit that we want to use. Okay, and we see that it says about -20.13. This is acceptable. It's going to be a little higher, a little lower. It's not going to be always perfect, but this is very close. This is an acceptable patch cable. Now, really, you don't want the reference cable to read any less than -21 dBm. If it does, then you may want to replace the cable. So we know that this cable is good, so what we're going to do is going to disconnect it from the detector port, and it's always a good idea to put dust caps back on. Then we'll plug in the 1300 nanometer side this time. Okay, notice it went back to under because we haven't switched the wavelength on the light source yet, so it's completely dark. So what we need to do now is switch both testers to 1300 nanometers. Okay, on the fiber owl, this is done by pressing the F3 key, and you can do that by pressing it twice. You'll see that it says 1300 nanometers. Now, on the dual owl, you'll see this Greek symbol lambda. This is the international symbol for wavelength. We'll press that once, and that will switch over to the right-hand side. Okay, now we notice that we have a level of minus 19.51. Again, this is a good power level. We're around minus 20, and we're not below minus 21. So we can say that this is an acceptable power reading. Okay, so we know that both of these mandrel-wrapped cables are fine. But what we need to do now is check the straight cable to make sure it is also fine. So the easiest way to do this is to first temporarily zero out this 1300 nanometer cable. So what we can do is either press F2, notice the zero, word zero here corresponds with F2, or we can press the 0 key. That'll do the same thing. So F2, and then what we'll do is confirm that we're setting the 1300 nanometer reference. Press F1 for yes. And notice that the power meter now says dB, and it says 0 dB, okay? And it tells us what our reference level is here. Okay, what this means is that we've now zeroed out our patch cable, okay? But what we want to do is we want to connect in our straight cable now. So we disconnect the patch cable from the detector port, and it'll go down to a low power level. This is not a problem, it's just measuring room light. We'll connect the mating sleeve onto the end of the reference cable. We will connect one end of the straight cable into the mating sleeve. And finally we'll take the other end of the straight cable and plug it into the detector port on the fiber owl. Okay. All right, so notice we have a near perfect patch cable here. So by adding the mating sleeve and our straight cable, we didn't change our reference at all. So this is perfect. Normally you will have a little bit of loss in there, and generally you want to keep it to about 1/4 dB or less. Whatever reading you get at this step is essentially what will be added into your optical loss measurement when you're actually connecting the testers in to the link under test. But for now, we've checked our patch cables. They are all good, and we're ready to take our measurements.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL technical support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.